Okay, so we are going to continue with the lesson number 28. Today is the second session. Okay, so turn to the page number 221. This 28.3 compounds of carbon. So yesterday we learned the introduction and then we learned the physical and chemical properties and certain information about the carbon, and then we learned the allotropes of carbon, diamond, graphite, and fullerene, and synthetic allotropes also. Now we are going to learn the compounds of carbon. That's nothing but your carbon dioxide and carbon monoxide, how they are prepared and what is the physical and chemical properties. Okay, yes, we continue.
28.3 Compounds of carbon. The compounds of carbon can be classified as organic and inorganic compounds. Earlier, the organic compounds were defined as those compounds which originated from living organisms, but it's now possible to synthesize organic compounds in the laboratory. Therefore, they are now defined as compounds of carbon. The compounds of carbon which are not organic compounds are called inorganic compounds. Most of the inorganic compounds are obtained from various minerals. For example, limestone, marble and dolomite contain carbonous carbonates. The other inorganic compounds and carbides of metal, example CO2, calcium carbide, HCl, CH3, and oxides of carbon such as carbon dioxide and CO.
Okay. Yeah, I'll finish up this stuff. Sorry. So basically, the compounds of carbon is of two types, that is organic and inorganic compounds. Okay, organic means it is made only of carbon, hydrogen, oxygen. Okay, and sometimes few quantity of sulfur, nitrogen may come inside. Yes, these are called as, this is called as organic. So organic means it is made up of carbon, hydrogen, oxygen. In rare cases, in certain cases, there is the involvement of small quantity of nitrogen and sulfur. Okay. Now, where inorganic compounds means which we get in the form of minerals and salts. Okay, they are telling the example here. Underline this. Okay, limestone, marble, dolomite contain carbonous carbonates, that is 3 CO3. Carbonates means CO3. Okay, in the form of this limestone is nothing but your CaCO3. Okay, now in other inorganic compounds are carbides. Underline carbides, they'll be in single. Okay, singular. So example CaC2, that is calcium carbide, and HCN is called as cyanide. It's called as cyanide.
Ma'am,
Okay, and write it down.
HCN is hydrocyanic acid.
So you can write as cyanide. Okay, Cyanide. Cyanide, cyanide. And CS2 is called as carbon disulfide. Carbon disulfide. So I'm sending the spelling in the chat box. Cyanide, carbon disulfide. And the oxides of carbon is nothing but when a carbon is attached to the oxygen, it's called as oxides of carbon. Okay, so this is an oxides of non-metal. Am I right? Carbon is a non-metal. So what will be the nature? Acidic or basic? We learned in the last lesson.
I'm acidic.
Yes, it is acidic. So write it down in the bracket, acidic. So oxides of non-metal will be acidic. Oxides of metal only, they'll become basic. Is it clear?
Yes, ma'am.
Okay. Continue, Evi.
The organic compounds are obtained from natural sources such as plants and animals, coal and petroleum. We have studied in lesson uh, that plants and animals are sources of complex organic compounds such as carbohydrates, starch, oils, proteins, fats, etc. Coal gives us benzene, phenol, naphthalene, etc. Whereas petroleum is a source of petrol, diesel, kerosene, lubricating oils, wax and other compounds. In addition, a large variety of synthetic organic compounds exist and number is increasing daily. Thus, the number of organic compounds as compared to inorganic ones is very large. The properties of organic and inorganic compounds are different from each other. Organic compounds are generally low melting solids or liquids. They dissolve in organic solvents such as benzene, alcohol, chloroform, etc., but are generally insoluble in water. The inorganic compounds are generally solids which have high melting and boiling points. They generally dissolve in water but are insoluble in organic solvents. After having a general idea about the nature of compounds, let us now study the oxides of carbon.
Okay, so now they're talking about the organic compounds. So organic compounds are nothing but your petrol, coal, protein, oil, drugs, pharmaceutical drugs, everything is an organic. Okay, all these are organic. Okay, so when you compare the difference between the organic and inorganic, it's a little vast. Okay, so they have given us a para here. After the class ends, you will write in the notes. You just divide into two partition and write down the difference. First, in the organic will have a low melting and boiling point, where the inorganic will have high melting and boiling point. First difference. Okay, the organic solvents will dissolve. The organic compounds will dissolve only in the organic solvents. They are insoluble in water. Yes, could you able to understand? Organic compounds are soluble in organic solvents and insoluble in water, where inorganic compounds are soluble in water, insoluble in organic solvents. Yes, vice versa it is. Okay, so here the in organic compounds will be usually solid or liquid, but here inorganic solvents will be primarily it will be solids. So these are the three differences they are giving. Okay, yes,
Yes.
is it clear? Okay, low melting point, more low melting and boiling point, high melting and boiling point, solid and liquid. Your solid alone dissolves in inorganic solvents, it dissolves in water. Is it clear?
Yes, ma'am.
Okay, now go to the next one, oxides of carbon. Even continued 828.4.
8.4 Oxides of carbon. The two important oxides of carbon are carbon monoxide and carbon dioxide.
Okay,
Carbon
underline the
monoxide.
word carbon monoxide and carbon dioxide. So coming to the 10th standard, 15 and 14 years old should know the formula for the carbon dioxide. Okay, continue Abraham.
Carbon monoxide is formed when carbon or hydrocarbons are burnt in a limited supply of oxygen. 2C solid plus O2 gas gives 2CO gas. It is a colorless and odorless gas. It has a melting point of 199 degrees Celsius and boiling point of minus 192 degrees Celsius. It is a major air pollutant and is released in large quantities from automobile engines. Its low level poisoning causes headache and drowsiness, whereas its large amounts cause even death. It is toxic because it reduces the oxygen carrying capacity of blood by binding with hemoglobin, the red pigment of blood. Carbon monoxide has many uses which I have given below. It is used as a reducing agent in metallurgical processes to reduce metal oxide. For example, in the blast furnace, it is used to reduce iron oxide to iron. Fe2O3 solid plus 3CO gas gives 2Fe solid plus 3CO2 gas. In the presence of a catalyst, it can combine with hydrogen to give methanol, CH3OH. It forms carbonyl compound. Uh, the nickel carbonyl NiCO4 is used in the refinement of nickel. It is used as fuel. It is used in the synthesis of several organic compounds.
Okay, so now they're talking about the manufacturing of carbon monoxide, how it is produced. So just underline this equation with the like bold, highlight with the box. Okay, so 2 moles of carbon, not carbon molecule. Carbon is a non-metal. Okay, you cannot bring molecule out of carbon. Okay, so 2 mole of carbon it reacts with the oxygen molecule to give 2 moles of carbon monoxide, which is also gaseous state. Okay, which is also gas. So underline the details. It is colorless, odorless gas. Melting point is 199.0 degrees Celsius, and boiling point is 192 degrees Celsius. Okay, underline another word. It's a major air pollutant. We also call it as poisonous gas. Okay, when the level of carbon monoxide increases, there will be a headache. Again, if they are going to increase the level of more carbon monoxide, you will got drowsiness, and this monoxide will start to pass over all over the parts of the body through the blood, will be circulated through the blood. All the organs of your body will stop working, and there'll be silent death. Is it understood? Yes?
Oh, ma'am.
Okay. No.
Yeah, I mean, I said yeah, ma'am.
Okay. So here we have a movie which is completely based on this one carbon monoxide. The entire movie will be done. Okay. There'll be a human traffic person. Okay. What he will do now? Here from the North Indians, so many people will be coming here. Okay. So to do the what is that? Uh, day-to-day labor works for constructions or to work in the metro, all those things they'll be coming here. Okay, so they don't have family basically. They don't have family. They don't even have Aadhaar card, or they don't have smart card, nothing. So their existence in Tamil Nadu will don't have any proof. Okay, so the uh, human traffic people, what they'll do now, they'll cause they'll cause a accident. They create an accident actually. Okay, so for example, there's a person if named as Mani Abdina. This guy will know that this man has come from the North India, and he has no other cards, smart card, nothing, and he has nobody to ask something. So they'll create an accident. They'll hit him with some lorry or something, and they themselves will arrange a ambulance. Okay, that was not the original ambulance. Okay, so they'll pick up the guy and put it into the ambulance, and they'll go. In the ambulance itself, the person will insert the little amount of carbon monoxide through the veins. Okay, small traces of small amount of carbon monoxide will not be identified during the post-mortem. If a person, whoever the person is, the person dies outside the outside the house or outside the hospital uh, without any awareness, or if it's a suicide, they have to go through they'll be doing the postmortem. So while doing the postmortem, the traces of carbon monoxide will not be found. Okay, you cannot find. So they think they are dead because of the accident. Could you able to understand now? Yes. So that much serious consequences is causing. Okay. Now let us look at the uses. Okay, so it is first underline, it is used as a reducing agent. Okay, reducing agent in the metallurgical process. So basically here Fe2O3 Fe2O3 plus carbon monoxide gives Fe plus CO2. So they are releasing the carbon dioxide here. Okay, and in the presence of some catalyst, it combines with the hydrogen to give what? Methanol. It's an alcohol. Okay, so who has a habit of using the Head and Shoulder shampoo? Nobody. Nobody. Okay. Yo,
Yes,
Avram. Yes. So earlier, no, Head and Shoulder is very known for that dandruff. Okay, anti-dandruff. So they use this methanol as one of an ingredient. Okay, this methanol is not good for the eyes actually. Okay, so that time our syllabus was little good, where we used to learn the methanol about methanol not in the ninth and 10th itself. Okay, so just I was looking at the ingredient. I think I'm doing 11th or 10th something that time. Okay, so I think the pink color packet or blue something. Okay, it has methanol. So whenever I wash the hair with that head and shoulder, I'll get some uh, cool, some cool feeling will be felt. But along with that, you will after for a while, for a 5 to 8 minutes, you cannot open your eyes properly. I don't know whether it happened to me or somebody else. Now I think the power is reduced actually when compared to that time. After that I didn't use the head and shoulder. That's another story. So methanol, you can. This is one of the thing for the methanol. But methanol is basically used to kill the some fungus. Okay, because the dandruff is a fungus. Okay, and then it forms carbonyl compounds. That is nothing but CO is a carbonyl. Okay, CO3 is carbonate. CO is called as carbonyl. Yes, make it clear. CO is carbonyl when it comes to compound, when combined with somebody else. CO, when it is separate, we call it as carbon monoxide. CO3 is carbon dioxide. CO2 is carbon dioxide. CO3 is carbonate. I'm repeating again. When the CO is combined with any metal, we call it as carbonyl. When CO is combined with any metal, it is called as carbonyl. If CO is isolated in a free state, we call it as carbon monoxide. CO2, you know where it is carbon dioxide. CO3 is carbonate. Is it clear? Yes. Okay. Now, and you can use it for the fuel and synthesis of various organic compounds. We'll be looking at the how they're producing the several organic compounds by using the carbon monoxide for okay, in short. Now let's continue with the carbon dioxide, right?
Yes, ma'am. Okay. Um, Carbon dioxide is formed when carbon-containing substances are burnt in excess of oxygen. Heat, solid plus O2 gas, CO2 gas. CH4 gas plus 2O2 gas gives CO2 gas plus 2H2O liquid. It is also produced by heating of carbonates. CaCO3 solid gives CaO solid plus CO2 gas. It is also released as a byproduct in the fermentation of sugar to produce alcohol, ethanol. C6H12O6 glucose aqueous gives 2C2H5OH ethanol aqueous plus 2CO2 gas. Carbon dioxide is colorless and odorless gas. It is present in very small amount, 0.03% in the atmosphere. It is a major contributor to the greenhouse effect about which you will study in lesson 12. The main uses of carbon dioxide are as follows. Solid carbon dioxide, also called dry ice, is used as a refrigerant because when it is at an atmospheric pressure, it condenses into a solid rather than as a liquid. This solid sublimes at minus 78 degrees Celsius. It is used in the production of carbonated drinks. It is used in the production of washing soda, Na2CO3.10HO, and baking soda, NaHCO2.
Okay. So this is a very important question. They may ask you write the ways of manufacturing the carbon dioxide, producing the carbon dioxide. Okay, carbon dioxide. We have four ways here. When carbon reacts in the burnt in the presence of oxygen, lim, uh, unlimited or excess supply of oxygen. See, carbon, when it is burned in the limited supply of oxygen, it is producing carbon monoxide. When carbon is burnt in the excessive supply of oxygen, it is producing carbon dioxide. Is it understood?
Yes,
Yes.
ma'am.
This is the first way. Second, methane, that is CH4. Under below the CH4, write down the name of the compound, methane. Me, below the CH4. Below CH4, you write methane. Okay, methane plus oxygen gives carbon dioxide plus water. Okay, and then they are taking the calcium carbonate. CaCO3 is called as calcium carbonate. Write it down. Calcium carbonate, or it's also called as limestone. Chemical name is calcium carbonate. Commercial name is limestone.
Yes.
Okay. So it gives calcium oxide, CaO plus CO2. So CaO is called as CaO is name is calcium oxide, or it is called as quicklime. So calcium carbonate, when it's burned, it is giving you calcium oxide plus carbon dioxide. This is the third way. Fourth, finally, glucose, which is present in your all the fruits. Okay, imagine you're taking all the fruits, smashing it out, putting it in a steel container, and leaving in a open for a very long time. You'll get us like a strong smell, right? Alcohol, because of this fermentation. Okay, so glucose gives ethanol plus carbon dioxide. Okay, so how do we found out the liberation of carbon dioxide? When you take the carbon dioxide, insert it into lime water, the lime water turns into milky. Lime water means not lime juice, not that one. Yes,
Straight line.
slake lime. That is CaOH twice.
Yes, ma'am.
Okay, is it understood?
Yes, ma'am.
Okay. Now underline their properties. It is also colorless, odorless. It's present in the atmosphere for 0.03% only. Only because of 0.03% we are getting global warming, ozone layer depletion, all are happening. Okay. And next, then let's see the uses. Okay. So you could have underline this is very important. Dry ice. Dry ice are nothing but solid carbon dioxide. It's called as dry ice. It is used in the refrigerators. This is why I keep telling these kids not to eat the ice from the refrigerator. Do anybody has the habit of eating the ice from the refrigerator? Don't eat it. It will suck your blood. Okay, it will suck the blood. Okay, and then it is also present in the carbonated drinks. I already said during the what is that? Lesson number 8, acid bases salts. I said right. So when they've had only little amount of flavor, not even the fresh juice flavor, some chemicals, recoloring agents. Pour water, insert carbon dioxide. The water and carbon dioxide reacts and forms bicarbonates. Okay. Yes, and then it's also used in making the washing soda and baking. This is the only good purpose, I think so. Okay, underline this. Production of washing soda and baking soda. Production of washing soda and baking soda. Guys, memorize the formulas of baking soda, washing soda, everything. One day I'm going to keep a test silently. That's going to happen. Okay. Do anybody has any doubt in the manufacturing of oxides of carbon?
No, ma'am.
Sure.
Yeah.
Okay. Can we proceed to the next one?
Yes, ma'am.
Okay. Joanna, continue with the 28 point.
28.5 Hydrocarbons. As the name suggests, hydrocarbons are compounds which contain only carbon and hydrogen. As we have studied in lesson dash, the main source of hydrocarbons is petroleum. Hydrocarbons can be divided into various classes as shown in figure 28.4.
Okay, you leave that. Go to the next page. Read the aliphatic that one.
Aliphatic hydrocarbons. The word aliphatic is derived from the Greek word aliphar, meaning fat. Aliphatic hydrocarbons were named so because they were derived from fats and oils. Hydrocarbons can be acyclic compounds, which are straight chain compounds, or cyclic compounds, which have rings of carbon atoms. Aromatic hydrocarbons. The word aromatic is derived from the word aroma, meaning fragrance. The aromatic compounds have a characteristic smell. Structurally, it includes benzene and its derivative. The aliphatic hydrocarbons can be divided into two categories: saturated hydrocarbons and unsaturated hydrocarbons. In saturated hydrocarbons, carbon atoms are linked to each other by single bonds, whereas in unsaturated hydrocarbons, multiple bond, double and triple bonds are present between carbon atoms.
Okay. So now go to the flow chart. Okay. I already said you what is hydrocarbons. Hydrocarbons are compounds which is made up of only carbon and hydrogen. So these hydrocarbons are basically classified into two types: aliphatic or open chain, cyclic or closed. Okay, how does the cycle looks? Actually, it is closed. Am I right? Cycle. Okay. So aliphatic means there will be straight like chain. Okay. Cyclic means it will be closed. Okay. Yes. Now this aliphatic is further classified into saturated and unsaturated. Okay. Saturated means these compounds are made only by single bond. Do you remember we learned the lesson number 7 covalent bond? Under this we learned three bonds: single bond, double bond, triple bond. Yes.
Yes, ma'am.
That single bond is used to make used in the making the saturated. Yes.
Yes, ma'am.
Okay. So under the saturated you have only one class, that is called alkanes. Is it clear?
Yes, ma'am.
Alkanes. Okay. So under the unsaturated we have two classes, that is alkenes, alkynes. See, when you pronounce you feel it's similar, but look at the words: alkane A, alkene E, alkyne Y. Yes, is it
Yes, ma'am.
understood?
Yes,
Okay.
ma'am.
And then when you come to the cyclic or closed, that is closed, it is further classified into two types: alicyclic and aromatic. Okay. Alicyclic, you will have these compounds will be made with less than 6 carbons. Less than 6 carbons. Is it understood?
Yes, ma'am.
Aromatics are made more than 6 or more than 6. Okay. Why do they are called as aromatic? Na? You could have read in the Bible, right? Aroma, flavor, odor. So basically these compounds will produce a good smell. They'll produce some significant odor. Is it understood? That is why they are called as aromatic. Is it clear?
Yes, ma'am.
Yes.
Yes.
Okay. You could have seen that Amma using the phenyl in the bathrooms, right? Yes.
That's all.
Yes.
Yes, ma'am.
Phenyl. Okay. Phenyl is nothing but an aromatic compound. You'll get a nice odor, right? Okay. We people have certain favors. Okay. Certain people will be liking the old book smells. Okay. Petrol smell.
Yes, ma'am.
Yes.
I do.
I actually basically I love the petrol smell and the phenyl smell. When I tell phenyl, they'll laugh, but actually the phenyl has a good smell when it comes to the perfume what they're using now. But we cannot use it as a perfume, but still I'm telling you. Okay. So uh, so this is the difference between alicyclic and aromatic. Are you clear with the classification alone? Yes? Okay. Now go to the next page. Underline the word. The aliphatic is derived from the Greek word alipher, means fat. They'll be looking little bulged. Okay, bulged. They'll have carbons. Is it clear? Yes?
Yes.
Okay. That's it. Okay. Now we are going to enter into the actual important concept of this lesson. Yes? Okay. Now give me a minute to open the textbook, everything. Okay, I think I will stop till this, because if I stop, if I start, I have to finish stuff. 20 minutes will not be enough. Okay. Okay. Do you have any doubts as of now with the things whatever we learned the introduction of hydrocarbons also? Do anybody has any doubts with the hydrocarbons? What we learned?
No, ma'am.